We're at Embedded World 2022. We're here on the Lattice Semiconductor stand, and I'm talking to Mark Hoops from Lattice Semiconductor. Now, this is a really interesting looking demo. There seems to be an awful lot going on here. We're talking about factory automation. What is happening here?
Sure, so this is showing off some of our Lattice Automate solutions for factory automation. What we see here is multi-channel motor control. We're driving these motors using some of our development kits, and these are all meant to be showing off a distributed sort of machine with each board connected via a real-time Ethernet connection. So that's performing the sense and control. And it's a Lattice protocol, similar to like EtherCAT or other types of protocols, but it's smaller and more compact. You still get the real-time ability to do the sense and control of a machine, but it's lighter weight, lighter protocol, and good for within a machine.
Right.
And so what we're showing here is 4 different motors. We have a main board that is connected through OPC-UA to the cloud. So you have cloud to machine communications.
Yeah.
And we're driving each of the motors. These are BLDC motors, so we have a reference design for that. And then we're also showing off the capability to do predictive maintenance. And predictive maintenance, here you can see a waveform that
That looks a really random image to me.
Yeah, it doesn't make a lot of sense to us. But what this is a manipulated voltage and current waveforms. And what we can do is we have an AI engine embedded in the solution, and it is learning what a normal VI curve would look like and characterizing that. So if there's any degradation over time from bearings or windings or something like that, that would first be shown off as a distortion of the VI waveform, and that would then trigger an early warning to say, hey, you'll have to do some maintenance here.
Okay, so in layman's terms, the AI will learn that, and if there are any differences, it can then flag up the differences. But
Yep.
What about, so if the image changes, it'll tell you that something's wrong, but what about using a sensor instead? Why
Well,
wouldn't that be the
you
way
could
to
do
go?
that, but there are a couple of drawbacks. For one thing, usually if you have vibration or maybe temperature, then it could be later in the cycle and you don't have much of a warning time before the machine could shut down and have severe problems. So this gives you the earliest possible warning, because before you have high temperature, before you have a really bad vibration or something, you get an earlier view into it. Plus you don't have to add sensors. It's an integrated part of the solution.
Okay.
So it's cheaper.
Now that is a real selling point.
Yeah.
Well, thank you for walking us through that.
Sure, my pleasure.